So the next payment method is more common in real life, which we call the equal payment. So basically, we are having the same amount loan, $350,000 with the 9% interest rate for 15 years. Equal payments is basically everything will be equal, including the interest. So therefore, if we first want to calculate what will be the payments amount, in this case, using the payment function that we learned before, PMT, rate will be 9%, number of time periods will be 15. The present value in this case is the loan amount that we put a negative sign in front of this $150,000. And you can either leave the future value blank or put a 0. They both work as the same thing. If we do this, we will have to pay $43,420.61. So this including everything, including the interest and the principal. So let's make the calculation for this annual payment amortization table. This will be slightly different. The beginning balance will be the loan amount, the total payment, which will be this equal payment, and the same thing for every year. We press F4, and the interest paid, again, interest payment will be simply the beginning balance multiplied with the interest rate. We press F4 for the interest rate as well, so that we can always referring to this 9%. The principal payment in this case is the difference between total payments minus the interest paid. Okay, so we know the principal payment in this case is $11,920.61. So the ending balance in this case will be equal to beginning balance minus the principal. Again, keep that in mind. The ending balance will only take account the principal payment, not the total payment. Therefore, for the next year, beginning balance will be the ending balance for year one. And then we're pretty much done with everything, right? So now we want to drag all the equation one by one. Don't worry about it. There's nothing here. And again, as I said, one thing that you need to check is whether the ending balance is 0 at the very end of this loan payment, right? And we want to calculate the total payment as well. This one. Total payment will be $651, and interest paid $301, and the loan amount is $350,000. If you compare these two, so you're paying more than those equal principal payment. You're paying more than this schedule. The good thing about this payment schedule is you're paying everything equal every year. So you don't have to worry about like you're for short of money or something. You know exactly what you're going to pay. And the problem with this one is you're paying a lot more at the very beginning, much fewer at the very end. Again, this equal payment method is more common in real life. All right, so let's look at the last loan type, which we call the balloon loans. Balloon loans are loans that are amortized over a long schedule, but at some point during the life of the loan, the remaining principal of the loan is repaid, right? So basically, if you look at, if we are having a $250,000 loan, and this loan has an amortization period 30, and the time balloon payment due is 8. So basically, we're going to make the 9-year payment, and then after 9 years, we're going to repay everything for the loan. Right? So the payment per year will be 12. The interest rate is 9%. So here, I want to talk about one thing that we haven't touched a lot so far is if you notice these two things here. So the payments per year is 12. The interest rate, which is APR, 9%. Basically, this interest rate quoted is 9%, right? But this payment is 12 per year, right? 9% is for 1 year, but within 1 year, we're going to make 12 payments. We need to adjust this interest rate in our calculation. So let's look at this one, right? So the first one is based on the original amortization schedule, the monthly payment will be, right? So we want to calculate this payment, right? The rate in this case should not be 9%, but 9 divided by this 12, which is E118 and comma. The number of time periods is not 30 because this is 30 years. We are making 30 times 12 years, right? The payment itself will be 30 times 12, which is 360. E116 times E118. Present value is the loan amount minus or negative loan amount. And future value, again, we can say this is 0 or we can leave it blank. If we do this, we know our monthly payment will be $2,011.56. So this is how much we're going to pay. Because this is the balloon loans, we're going to make the payments for 8 years. And then we will have to repay the rest of the loans after 8 years, right? So basically, the balloon payment is present value of the remaining payments, right? So the present value of the remaining payments. How do we calculate the present value for the remaining 22 years? So basically, let's using the PV function here. The rate, again, will be 9 divided by 12. Number of time periods, right? So remember, we have already paid for 8 years. The loan is for 30 years, right? So the number of periods will be the difference between 30 and 8. And the payment, right? So the payment itself, we know this is, we are going to make $2,011.56 payment, right? So we put the negative sign for the payment here in comma, and we put a 0 for present value. That can give us the present value for the balloon payment, remaining payment, right? If we do that, that will give us 40,656.0. That's how we calculate it. As you can tell, using Excel is much easier and more sophisticated than give you the number right away. Another way that we can make balloon payment, rather than make two-step calculation, we can use what we call the nest one function inside another, right? So we can calculate the present value because the balloon payment is a present value. The rate will be divided by 12. The payment number of time periods will be 30 minus 10. Oh, my fault. Here, I make a mistake here. So when we talk about the number of years payment here, so I say this is 30 minus 8, which is wrong because it's now 22 years. Within a year, we are making 12 payments. So we have to multiply these by 12, right? So that's the total number of payments, right? So as you can notice, when the payment frequency and the interest rate are quoted in different frequency, it's very easy to make this kind of mistake. So the balloon payment will be actually 230,901.73, right? So let's go back to this nested function. So the present value, we will have this 9% divided by 12, which is our interest rate per month. The number of time periods will be, again, 30 minus 8. We put the parentheses here, times this 12, okay? And the payment, if we don't have this payment yet, we can always calculate the payment using the nested function, right? So we can always calculate this payment by calculate the payments for monthly payment for this loan. The rate is 9% divided by 12. And the number of periods will be 30 times 12. And the present value is negative $250,000. Future value is 0. Notice one thing here. Payment, if we make the calculation, payment will be positive, right? In order to have a positive future present value, we want to have a negative payment. So I can either put a negative sign here, or I can just put a positive sign for present value in this case. Either way works fine. If we do this, so we are going to get the number that is the same as we have shown above. So that is for section 6.4. And I also mentioned one thing. At the end of the day, I need you guys to be able to make a loan amortization table, something like this. Right? So if you were given a loan amount, $275,000, the annual interest rate, okay, pay attention here, the interest rate is 5.3%. Okay, so this is per year. And the loan period is 30, but we're going to make 12 payment per year. So we're making monthly payments. And I would like you guys to be able to come up with a table like this. So the difference between this one and the one that I just showed you is simply, this is the monthly payment and it's much longer time periods. But other than that, everything should remain the same. So that'll be it for chapter 6.